Okay, others will join in between. Am I audible? Shruti, am I audible? Shruti, are you there? Nivrutti,
Yes, sir.
Sidhe? Okay. So there is another thing. Actually, I wanted to ask you people. Uh, anybody else is there in the campus on Friday? Actually, our lab, Mechatronics lab, it is combined lab, measurement and mechatronics. So that lab is totally renovated and upgraded by one of the contributions from alumni. He is actually your senior, and so that lab opening is there, or you can say inauguration. So if some of you are anyway there in the campus, so I would like to invite to those students for that lab inauguration. Anybody is coming over there in the campus, maybe for say activity, SRA activity, or maybe for project work. Anybody is there around? Later on, it is the same lab where you all will be performing the experiments, if it is allowed later on. Nobody is there. Nobody is associated with SAE activity, or I will talk to Professor Wankade and Tendulkar sir. So those coming over there.
The final year students are not involved, only third years do that.
Acha, acha. So nobody is coming right now to the campus for say for project work also. If some of you are coming, maybe 4 5 students, that is sufficient. Rest of the second year students are coming on that day. So if somebody is there from final year, then we can just give your introduction over there. Okay, if somebody is coming, let me know so that we can make such arrangements. Some activities are being planned over there. So last time we started with this uh, low cost automation. Now there was quite a big gap, so I was not well. So I could not conduct it. But anyway, uh, tomorrow I think tomorrow also lab session is also there, na Atharva?
Oh, yes, sir.
Okay. So uh, all of you have downloaded that software or still to download this? I'm again typing it over here. This Fluid Sim software. It is in the chat box right now.
Sir, but how? Sir, there is no official source, I guess.
Yes, Amar.
Yes, sir. From where to download?
Are you don't know? You just type it into the Google.
No,
Free.
sir, but they only have 1 month free period, so we can only use it
Yeah,
for
that.
1 month.
Yeah, that is sufficient, Atharva. We don't need it for too long. Maybe 1 or 2 weeks, or 2 or 3 maximum 3 weeks. We need that software. Then what you will be doing? You will be forming the circuits over there, and you will be taking screenshot. And those screenshot will be submitting as an assignment. That's all. Then we don't need it because we are already
Okay, sir.
doing it for the MTech
Okay.
students. So MTech students have already submitted their 2 assignments. Those assignments are with me. So we are already doing it with the MTech. So similar thing will be done for your BTech for the time being. See, anyway, later on, if there is some possibility you're coming to the campus, then that time again you will have a experience of handling physical setups over there. But till then, we will just continue like this. Okay. So and it is a very it is not much of the size. I think 50-60 MB size is there. So it should not be a much problem because without that nothing can be done for this particular chapter. If you don't have this software, you can't do anything over there. And more importantly, to understand, you might have seen these videos and everything now so far. So if you are having those equipments being operational, or how do they connect different things, then only you will be able to understand. This is highly practical aspect. Means just by studying theory, probably you will not be able to understand this chapter and this entire low cost automation. So you need to have either software, or you should have physical handling of the equipments. So these are the only two things possible. Okay, so all of you download today itself. Whatever you can see, I'm not insisting you should download this and that version only. 5.6, if you are able to do, it's okay. Some of you are able to do 6.12, that is also okay. Basic library is same, so it won't make much of the difference. Arnav, you wanted to say something?
No, sir. No, sir.
Okay. Okay, so you all of you try to download it today. So we will be starting tomorrow. So at least some basic circuits, if you are able to do, you will understand on your own. It will be similar to what is being explained earlier. What videos I have forwarded to you. So one of the videos have already explained to you how to form different circuits, and we don't need very complicated circuits. Basic intention is that you should be able to understand. Yes, yes, Nikhil. Yeah, correct. So rest of you can also access the similar link. So we will move on further. That is, we started with the 2 by 2 wall. Now this 2 by 2 wall, as the name suggests you, there are two ports. Two ports means in and out directly, that's all. And two positions means on and off position. So these two positions are possible for this wall. If you have seen earlier the cross sectional diagram of this, you'll be able to understand it clearly. So you can go through that cross sectional diagram. Then next is about how to form different circuits using this 2 by 2 wall. So how to form different circuits means what? Before directly starting with the circuits, I think last time we have seen it, but I would just like to give you the logic behind this. See, there are applications like we call them in exact industrial practice conveying operation. Conveying means you are along the conveyor belt. Different parts are there, so you just want to convey them from one station to another station. Then there can be a possibility of clamping operation. You just clamp over there, put it somewhere else. Sometimes you will require hammering operation. That is, hammering effect is to be given to the parts which are placed over there. So such simple operations you need to perform in industry. So how will you do those operations? So either you can have that piston cylinder arrangement. So with that piston, you can have some of these operations, or there some specific attachments attached at the end of the piston, so that maybe clamping or some other operations you can do over there. So all these are very common operations, and this can be done very simply with the help of this wall, 2 by 2 wall. So how to get circuit actuated? So there are two things. You can just connect this 2 by 2 to the cylinder. Say you are using single acting cylinder. So as the name suggests, you are giving air supply from one end, it will go outside, outstroke will occur. Once the exhaust occurs from the other end, when you push from the other end, exhaust will occur, and with the spring force, it will come back to the original position, that is in stroke. So this way you can apply your logic, and then you can start forming the circuit. So this is what happened when last time also I told you people that maybe some activity I have given to you, and if possible you can send it to me. So few students have actually sent it to me. I have given them a reply also. So it is good that those students have been able to imagine without actually seeing this now in physical instruments, but still they are able to do it. So it is good thing. So that way you will have to imagine both the positions, and then in both the position you can show the connections and then achieve with the help of maybe push button, sometimes it may be roller, sometimes it is total spool movement with the help of pressure. So lot of things are possible over there. So this introductory part we already have started over there. What is happening? Mm, okay, now it is coming over there. So we have studied this particular circuit, 2 by 2 wall actuator control. This is very easy circuit. Quickly I will just go through. No, I'm not able to recall uh, how much we have studied last time. So it is obvious thing, 2 by 2 two walls are used. One wall will give outstroke and one wall for the instroke. So simple logic is being applied here. You can see the position of air connection in the next switching position when you will be pushing the push button. So from here, in this particular case, you will be using this for outstroke. You are pushing the push button, it will apply pressure over here, piston will come outside. When you are pushing this particular in push button, then exhaust will occur. So this exhaust is indicated with the spring force, it will come back. So simple logic is being applied over here. So this is actually what happens if you are pushing the push button, the button marked out is pushed, then air is connected. Those, this is how outstroke will be there. Again it will remain same. Once you are pushing over here, we can see the switching position right now. This is 1 to 2. Now that stroke has completed, unless you put the other side will be there. Then this is the next position. When you are pushing over there push button, this is something similar will be there. That is due to the spring. Now you are already familiar. Stiffness of the spring is there. So due to that force, due to the stiffness, it will arrange in stroke. So this is what happens to 2 by 2 wall. But now this is the complete cycle of operation has occurred. One outstroke, one in strokes. So once you have completed, then the next what you can suggest for this kind of circuit. So to make all your circuits flexible enough, lot of other things you can add to these circuits. As I told you earlier, you can have suppose all of you have studied some C programming or some other languages. So for same application, you can have the different circuits or sorry different programming. Similar here for same application, all of you can suggest different other things like now addition of walls is possible. You can see variable walls being added over here. So this is variable wall. Then this is another variable wall. So why these variable walls are arranged over here? This is actually there are two aspects to it, but one aspect is totally design aspect. If anybody else is knowing, pneumatic system have got one uh, peculiar characteristics. If anybody knows to address that characteristic, these walls are very helpful. So anybody aware of that characteristics of pneumatic system? Yeah, this actually thing probably if you could have performed in the lab, you could have easily noticed it. You simply push it over there, and immediately there is a what we can call it as a generation of shock waves. There is sudden application of pressure. So if so to absorb that pressure, there shock waves are created, and that is actually one design problem that we are facing. Noise is generated over there. There is uneven wear that is caused due to this particular characteristic of the pneumatic system. So obviously, if you are putting over there variable walls means it is similar to your orifice kind of arrangement. So for that, you can regulate air air pressure. So if you are able to regulate, then obviously you can control that stroke, and then with that, you can avoid such phenomenon of noise creation, vibration creation. So that can be avoided. So it is one of the most important things. With this addition of variable walls, you can ensure that is one thing. What can be the other possible application? So that is being explained here. That is, you can control stroke independently in both the directions. If you are putting the now this wall, you can say this wall connected to the out, and this wall connected to the in. So in both the directions, you can control the speed. There are a lot of applications where you don't need uniform speed. You may require acceleration in the working stroke, or maybe sometimes in deceleration and return stroke. So as per the different applications, you can regulate it. So with that, this addition is important. That is addition of these variable walls. Now this is their variable walls we have adjusted. Okay, so slowdown can be there. What other things we can do? If you remember the entire list of walls and other things that we can incorporate into the pneumatic system, probably you will be able to comment on that. What other suppose the present circuit you are observing, what else you can do to improve the performance of this same circuit? It is there in the next diagram immediately. So you can just try, or we will move on to that next diagram. No, see, we have seen earlier. I will show you that thing being included over here. So this is what the pressure gauge. I told you earlier, most of the times these pneumatic systems are preferred to operate in the range of 3 to 6 bar. This particularly you could have realized over there in the lab. We used to control the pressure till say 5 bar. If it goes beyond 6 bar, so entire setup can explode. So you can find out over there that there is a pressure gauge connected to that line. So it is the most important connection over there. So we need to always monitor how much pressure is being generated by the compressor, and then it is supplied. So you can understand that pressure application, and if it is exceeding 5 bar or 6 bar, you can restrict it. So obviously this is making your circuit more flexible, and you can monitor so many things with this circuit. Now with this circuit you can monitor the flow rate also. That is, you are controlling the flow rate over there. You are monitoring the pressure also in the um, uh, given to the cylinder. So both these things you can monitor in the present circuit. There are other things when you go for that software. This exercise you can do on your own, or tomorrow also I will tell you that exercise. If you double click on any of the components, you can take for example cylinder or wall, whatever it is. If you double click, you will get the properties of that particular element, and then you can reset those properties as per your requirement. Sometimes you can increase the pressure, sometimes you can reduce it. You can adjust with the dimensions, diameter, length, all those dimensions you can adjust so as to give you the required force. So this is purely the design aspect of circuit right now you're observing, and similar thing you can do it into the software. Here you may not be able to imagine it. Now this was about the 2 by 2 wall. Suppose now we are using 3 by 2 wall. 3 by 2 wall means what? There will be 3 ports and again 2 positions possible. 3 ports are there. If 3 ports are there, then I can just give you 1 or 2 minutes. You can try that connecting 3 by 2 wall to the cylinder. You just try it on your own. No need to show to anybody. Later on, when the immediately circuit comes to you, you will realize to what extent you have done it correctly. So I just want you to try activating cylinder with the help of 3 by 2 wall. Just for, I'm giving you 1 or 2 minutes so that you will also come to know sign conventions are important. So those some of those who have sent me the pictures, you have to be very correct when signs nomenclature is being used over there. So that nomenclature has to be followed. If you are drawing something else, it means something else. So it is not accepted. Whatever currently you are observing, same sign convention needs to be used. So you might have tried over there. So I just want to ask one simple question: can we actuate a double cylinder with the help of through by two wall, or we can actuate only single cylinder with the help of through 3 by 2 wall? Can anybody answer this?
Hello, sir.
Yes.
3 by 2 control valve can actuate single acting cylinder only.
Yes.
And for actuating double acting cylinder, we need 5 by 2 way control valve.
Okay, but why can't we actuate double acting with the help of 3 by 2? Any reason?
Sir, because it has only one port for the supply,
Okay.
and the double acting cylinder require two port for intake and exhaust. So that's why we require 5 by 2 way control valve for a double acting cylinder.
Uh, okay, see, the final outcome that you are expecting, that way you are presenting it is okay. But I want I'm expecting another very specific answer. With the connection of airport, if somebody can explain with the help of switching position. Now, suppose now in the default position, uh, piston is retracted condition totally. So in stroke is there. When in stroke is there, uh, we are supplying the air connection. Say for example, single acting cylinder. Okay. So now when we are switching the position, what will happen? And if we replace that single acting with the double acting, once we switch to the next position, what will happen? So from that point of view, I want if somebody can explain, or anyway it is there in the next diagram. So I'll be showing it to you. You just think about it. I will by that time we will complete the attendance. Ayush is there. Ayush, Abhishek,
Yes, sir.
Adesh, Aditi, Aditya Singh,
Yes, sir.
Present, sir.
Yes, sir.
Amar, Aniket, Anjali,
Present, sir.
Arnav, Arya,
Yes, sir.
Present, sir.
Ashutosh, Atharva, Bhagyashri, Bhushan,
Yes, sir.
Present, sir.
Sir.
Chaitanya, Gufran, Gurpreet.
Yes, sir.
Present, sir.
Okay, so the yes, Harsh, Harshada,
Yes,
Present,
sir.
sir.
Jay, Jayant,
Yes, sir.
everything.
Yes, sir.
Karthik, Kaveri, Manas,
Yes, sir.
Monil,
Present, sir.
Mohammed, sir, Mrutyunjay,
Present, sir.
Sir, model present, sir.
Yes, sir.
Mugdha, Munish, Neha Korde, Neha Kurian, Nikhil
Yes, sir.
Belda,
Yes, sir. Yes, sir.
Yes, sir.
Nishant, Nivrutti, Omkar, Praful, Prajakta,
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir. Present.
Yes, sir.
Pratik, Rahil, Rahul, Pancha, Rahul Yadav,
Present, sir.
Present, sir.
Rajiv, Rakesh,
Present, sir.
Present, sir.
Ravi Desai, Ravi Parmar,
Present, sir.
Ritvik, Sagar,
Yes, sir.
Present, sir.
Sakshi, Saloni, Sarang,
Present, sir. Present.
Udar, Sarthak, Sarvesh,
Present, sir.
Shlok, Shreyas,
Present, sir. Present, sir.
Shrikant, Shruti,
Present, sir.
Yes, sir.
Shubham, Shubhangi,
Present, sir.
Yes, sir.
Siddesh, Srushti,
Yes, sir.
Suraj, Tanmay,
Present, sir.
Tejas, Varun,
Yes,
Vedant,
sir.
and Vishwajit.
Present, sir.
Yes, sir.
So, can anybody throw some light on that particular issue, or I can show you the diagram immediately.
Yes, sir.
Huh.
So, sir, like if we consider 3 by 2 way control valve and a single
Okay, I
cylinder,
will show you the diagram also. Okay, yes.
Then during the intake stroke, the supply air will be come from port 1 to 2 and the cylinder will extend.
Okay, correct.
And since it is single acting cylinder, it has a spring for retraction. So when
Okay.
the supply air is removed, the air which is present inside the cylinder will exhaust from port 2 to 3 and the
Yeah,
cylinder will
correct.
retract.
Okay, fine.
Yeah.
Yeah, but then when we are putting over there double acting, what
Hmm.
is the issue? Why it is not working?
Sir, since double acting cylinder does not have any spring for its retraction, so
Okay.
we require two ports for double acting cylinder, one for the intake and one for the exhaust.
Yeah. So
Yeah. So
suppose okay, suppose if I am putting instead of 3/2 4/2 wall I am putting. So is it possible now to achieve double acting cylinder?
yeah, sir, 4/2 it is possible.
Yeah. Okay. So correct. So Vedant, exactly correct is answer is there. It is due to the spring force. We can have this particular arrangement that is 2/2 as well as 3/2 for single acting. But then if it is not there, spring is not there, you cannot have this arrangement. Means we cannot have single 3/2 achieving the double acting cylinder. Now this is what we are discussing. You can actually try in the software directly. So you will come to know in software there is a blue line indicating the flow of air. So you will come to know where it is trapped and where it is not allowed to exhaust. So in that particular arrangement, you will be able to understand correctly what just now Vedant has explained. So from functional aspect, you can understand these things. And it is very important to know why one particular connection is working, why another is not working. Because even software will also just give you the message that this particular connection is wrong. So what is actually wrong, where it needs to be connected, that is all your job. So that always you will have to think and then you can report those connections. So here now in the present diagram, three-port wall provides inlet and exhaust path and is the normal choice for the control of a single acting cylinder. Now in the normal position produced by the spring, the wall is closed. In the operated position produced by the push button, the wall is open. So push button must be held down for as long as the cylinder is outstroke. So you want it to be in the outstroke position, keep it in the press position. If you release the pressure, it will come back. So this is, you can see the diagram. In the press position, 1 to 2 gets connected, air pressure is applied over there, and you will find it into the uh, outstroke position. Now this is the next position. In this position you can find out 2 to 3 getting connected, so exhaust is being provided with the spring force. It will come back to the original position or in stroke position. Though this is the next addition over there. So what is the next addition here? Again similar requirement is there. We need to control the stroke. So if that is the requirement for one particular application, you are having that requirement. If that is the scenario, again we will apply here variable wall. There is actually one more thing we can use in the similar line. What is that? It will you will be able to see anyway in the next few diagrams. But if anybody, because they that is also one of the important things in pneumatic connections. Can anybody throw some light over there? Say that here right now we're using the variable wall. Can anybody anything else can be used over there which will be more useful, which will add more safety or flexibility to the circuit?
Check wall.
Yeah, correct. Who was that? Who gave the answer?
I'm here from the phone, so I'm not able to make it out.
Pratik sir.
Pratik. Yeah, okay, correct. So check wall means why? Because check wall gives you another important thing in pneumatic connections. Sometimes there is reverse direction flow occurs of air. There are various reasons for that. So we want to again make it sure that it has to be uniform in direction. That is, it has to come from this. If suppose you are applying 1 to 2, immediate reverse stroke should not happen at any cost. So you want it to occur in only in one single direction, then you can apply check wall. By applying check wall, you will be able to give two different aspects. That is, variable flow will also occur, and whatever the flow is there, it is in unidirection. So both the things can be achieved by applying this check wall. I think it is there in the next immediately. So now in this current diagram, you can observe check wall is arranged over there. The purpose of check wall, as you know, the direction of this check wall is indicated as shown in the direction of the check wall. Is it now allowing air to flow from 1 to 2 or 2 to 3? In either reverse direction, the check wall is allowing, or in the other direction, it is allowing.
2 to 3 sir.
Yes.
It is allowing for 2 to 3.
Yeah, correct. So, in stroke only it is allowing, because the direction of the arrow is like that. So that direction you will have to draw very carefully. So if you draw it in the reverse direction, it means altogether different directions. So these are the sign conventions about which you will have to be very careful when you are drawing the circuit. Otherwise, what happens? You have drawn the entire circuit, but it is not giving you the intended application. That time you will have to cancel that circuit. Otherwise, that entire circuit will be wrong. So to control the outstroke speed of a single acting cylinder without controlling the in-stroke speed, a unidirectional flow regulator is used. This is the main intention of using uh, check wall. Flow into the cylinder closes the non-return wall and can only pass through the adjustable restrictor. By adjusting the restrictor, outstroke speed of the cylinder can be set. This way you can control that speed. Then for independent speed control in each direction, two flow regulators are required, installed in opposite directions to each other. Upper regulators controls the outstroke speed. Then lower regulator controls the in-stroking speed. So this is again another, you can have further improvement into the circuit. Some of you may just draw the wall, connect the cylinder, and then leave it as it is. Some of you can add another flow variable over there. Some of you can add one check wall, and some of you can add two check walls. So this way different circuits are possible. This was the arrangement in the earlier diagram. Now this is the arrangement you can see. So this is the possibility of using 3 by 2 wall. Now, as last time also, I think we can have that particular use of 5 by 2 wall. But basic requirement of this 5 by 2 wall is again another aspect, that is design aspect, to ensure that pressure variations can be adjusted within the same wall. So too many extreme variations are not being allowed there. So this is how 5 by 2 wall can be connected. So obviously we don't need a single acting cylinder now. In this particular case, we can observe that is to for perform. Now default position, if you are assuming as in stroke, in that case 1 to 2 should be applied air pressure, and then exhaust is allowed from 4 to 5. So that's all. The other remaining port remains in shut off condition. Here in this diagram, this port 3, it is shut off position. Both other four ports are connected. So for a double acting cylinder, the power and exhaust paths are switched simultaneously. When the button is pushed, the supply at the port 1 is connected to 4, and outlet port 2 connected to exhaust 3. The cylinder moves plus. So this is the arrangement. In the other switching position you can have, that is in the outstroke position. When the button is released, port 1 is connected to port 2, and port 4 is connected to port 5, and cylinder retracts. So that is the in stroke condition you can observe. Okay, so the link is also there for the attendance. So you can also fill the attendance right now. So this is first possible circuit for this 5 by 2. Obvious next circuits you can have, that is in outstroke is indicated. Now you can observe the port position here. What is the port position for this particular activity? 1 to 4 is getting connected, 2 to 3 is providing the exhaust, and 5 is in the shut off position. So for a double acting cylinder, so this is what other positions possible. Then this is the next one, that is what we have seen earlier also, that is we are adding here check valves. So independent speed control is the requirement. Independent speed control means for the outstroke as well as for the instroke, there has to be independent control. So for that, this arrangement is provided. In most applications, speed is controlled by restricting air out of a cylinder. Now full power is developed to drive the piston with speed control by restricting back the pressure. So the intention here is that if you are holding it for some time, then entire pressure will be applied, and then it can move with a very high speed. That piston, that is the suppose you are performing the operation like a hammering operation. So you need to strike it very fast. So entire, if you are able to provide the entire air pressure simultaneously by some adjusting certain variable conditions, then it is useful for some of the applications. So this is the possible position over here. Again, the in stock you can observe here in the in stock. So valves with a spring return are monostable and need to the operator to be held all the time that the cylinder is required in the plus position. So you need to keep it on pacing every time. Bistable valves will stay in the position they were last set. The lever valve example illustrated indicates a detent mechanism. The lever need not to be held once the new position has been established. So this lever kind of arrangement, actually we had almost similar arrangement in our lab. Lever kind of 3x2 wall we are having. So what they are supposing here, you don't need to put it into that position or keeping it pressed. You just put it lever over there. There is an arrangement, they call it as detent mechanism, so it will remain. Once you push the lever from the other side, then it will come back to the other side. So from both the ends this is possible. But another thing is there, sometimes these 5x2 walls actually we don't use at all this either push button or roller. Simply with the air pressure application, spool movement is taking place over there. That is entire wall inside, grooves are there. So that spool adjusts the particular port connection and the other spool blocks the other ports. So something that spool entirely moves from one end to other end. And what is responsible for that? So it is purely a pressure application. That time we are not using this 5x2 wall as a pressure wall or start stop wall. We are using it somewhere, we can call it as intermediate wall. So some other wall we can use as a start stop walls. To a simple 2x2 or 3x2 wall can be used, and that wall can be given connection to the 5x2, and then with the simple pressure application, it will move from one end to the other end. So this is what happens for this 5x2 wall. Okay, so I think we will stop here for today. Now slightly complicated circuits we need to consider. That is further possibilities there for the manual control. Then from totally manual control to the semi-automatic control we'll have to move. How the same circuit which is manually operated can be converted into semi-automatic, and then the fully automatic, and then further stages addition to that existing circuit. So this way the complications will improve further. So I think for today we can stop here. If any doubt is there, you can put it into the attendance sheet itself. We will try to resolve it. Okay, so all of you try to download the software tomorrow. So we will again meet over there. Okay.
Thank you, sir.
Bye. Okay. Thank you.
Thank you, sir.